Back in the Hack Shack with a little project using a 4060 timer. All this circuitry in this little box right here just to do this. Welcome to Hack-A-Week. Hey, it's 2014 and we're back at the workbench. It's good to be in here. It's actually nice and cozy in here today. I got the heaters on and it's nicely warmed up. And Fritz is over here with me today. He's resting well after a leg amputation. Fritzy lost that right leg. He had that limp going on for quite a while. We did everything we could to try to figure out how to save it and we really couldn't. So he lost it. It's gone. You know what? He's a happier dog for it. Fritz the tripod dog. Sophie's in here hanging out. We got the fish factory going over here on the other side. Some stuff Lisa and I are working on together there. So this is the kit on the workbench. It's from Tata Electronics. It's that third brake light flasher kit. I mentioned it in one of the motorcycle videos that I would probably start building electronics again doing this very project. I ordered it from Tata Electronics. I think it was about $25. Came with all the components that you see right here, including a perf board that is pre-tinned on the horizontal lines. I've never used one of these before, so I'm thinking what I'll do is just cut away the traces I don't need with a Dremel cutaway tool. That should work out alright. This is the PDF that you get with the kit. Everything's on here as far as the basic schematic, and then just some common sense kit building fodder, you know, the stuff they always tell you about being careful how to solder and things like that. I've laid this out on a piece of graph paper because then I can just duplicate what's going on the graph paper directly onto that perf board. It crosses right over quite well. Each place the lines intersect are where there's a hole in the perf board. So, and plus I just like drawing out a schematic on paper. It wraps your head around what it is you're about to arrange on the board. You can visualize where all the components go, and this is a pretty tight layout. I could expand this out because really by the time this is done it'll be probably half this size. Well, let's get to work on this thing, get it together, and then the plan is once it's all working and tested out, we can put it on the motorcycle and figure out a way to install it underneath the seat. I've got a little box here, a little project box that the whole thing's going to go inside of, and I'm thinking I can just cut a little space in the seat right in front of the tail light. There should be plenty of room there to stuff that in out of the way. It's got a little fuse in it that I need to get to, so I could set it up so I can do that, or I can just put the back on and forget about it and hope I never blow a fuse. But good to know the fuse is there. I digress. Let's get building this sucker. So here's the 4060. It is a 16-pin dip that's a dual inline package, dip chip, and it has let's see, 13 to 15 volts is the operating voltage on it. And inside here is an astable oscillator built into this. I believe it's a NAND and an AND gate. And what goes on in here is the oscillator runs at a frequency that you can set with a clock here, or you can set it with an external resistor capacitor arrangement. And that would be between pins 9, 10, and 11. And you'll see that more later in the schematic. But that oscillator frequency is then divided by all of these other pins, Q4 through Q14 in fact. So if I was to connect that output to Q4, would divide it by 16, and my output at 3 would reflect that. And then if you let it go to the next level, it would go times 32, or divide it by 32. So Q4 is 16, Q5 is 32, Q6 is 64. You can see it doubles each time as it goes along. So by working through the iterations of this and setting the initial oscillation, you can get virtually any kind of timing that you would like out of this device pretty easily. So let's take a look at that schematic here of the project, and you can see, let's see, make sure I get all of this on here. Right here is the resistor capacitor arrangement between 9, 10, and 11. Then here is a latching diode, a 1N4148 diode, and what that does is when it gets to pretty sure the way this works. If it gets to pin 13, which if I reference my sheet here again, that's Q9, that's divided by 512. When it hits that as the output, as it's working its way up through all of the dividing blocks, it latches and it stops. So that's what makes this circuit do what it does, which is to blink 4 times and then stop. And let's see, built into that resistor capacitor arrangement is a variable trim pot resistor, and that's there so that we can dial in precisely the timing we want. You can also hook up a external crystal to one of these and achieve the same thing. All right, let's see, let's get you zoomed in here a little bit closer. Got some music going in the shop here from freemusicarchive.com. Just randomly selecting some songs from the music for video selection. So what I'm going to do first is just lay everything out on the board as per my drawing. Get the dip socket on there first. That takes care of that. I'll bend those 2 outside leads on this PNP transistor. Bending the 2 outside ones keeps it in place. Then I'll solder in place the middle one, and I can straighten out the 2 outside ones and solder those in place. This is the transistor that will do the switching and make the light go on and off and blink, and that will be from the output signal from the timer. The timer being the 4060 timer that we're going to put in here. This guy, CD 4060BE, and it's basically a binary counter timer, and you can configure it for longer duration time delays and such. A little easier to use than a 555. If you have something that you want precisely to clock at every 48 seconds it does something, then this is the chip to use. Alright, the transistor is on there. What's next? Next, let's see, we've got a small resistor to get on there. I think that did the trick. When I'm putting these things together like this on perf board, I take a marker and I mark off what I've already done. That way I'm sure I'm getting the schematic right, and helps with the layout too. Next I've got to put this diode in. I've already marked it off just for the sake of showing that I've done it, but the diode has to go a certain way. And if you look really close at this drawing here, you can see the diode right there has a line on that side of it. That would be the cathode, and that goes to ground, and that goes to pin 8. That's the negative side of the LED. And the LED is right here. And it's hard to see it on this particular one because it's so tiny, but there's a flat spot on one side, and it's over on this side of the LED. There's a little flat spot on the actual plastic casting, and that is the negative side of the LED. So make sure you get those right when you put them on the board. And I'll get this one mounted up now between this 1K resistor, which is connected to the collector on the transistor, and pin 8. This is a little 1N4148 diode. Very common little diode. You can see there to the left is a black stripe. That would be the cathode, the negative side. And that goes in my circuit right about, let's see, where are you? Right here. You need to pay attention to those diodes and which way they are connected to things. Very, very important. This is a 1 microfarad electrolytic capacitor. That means it's polarized. It has a positive and negative. The negative is marked by a stripe like that with a negative symbol on it. You can see that it's 1 UF meaning microfarad, and it's 50 volts. So if you're way over on the voltage, you're safe on a capacitor choice in a circuit. A lot of people ask me, what's the right voltage? As long as you go over the operating voltage of the circuit, then you're okay. As long as the microfarad matches up, then you're alright. So we'll install this one now with the proper orientation, positive and negative. Right there is a ceramic capacitor. I just installed that one, and there is no polarity to those. There's no positive or negative. You just install them where they need to be. And that's a little resistor I just put in that's also not polarized. It can go either way. Just make sure you use the white wattage. Make sure you use the white wattage. That was Kripke intervening there for a moment. Yeah. This is a little 500K adjustable potentiometer, variable potentiometer. Not like a volume knob style, really tiny style. It's got 3 leads on it, just like any other potentiometer. And it is 500,000 ohms and very easy to drop. Yes, so that's got to go on the board here next. Right there. I've got some connections now, some hookup wire here that will go on a few various places. There's basically power in, power out, and ground. The green one will be the ground. That'll go right here on the negative side of that capacitor that I just installed. And a fuse holder. Gotta have a fuse on our project. One last wire, the red one. The all-important red wire, that's the power input from the brake light switch. Let's mount the chip into the dip socket. Yeah, I know I don't have any electrostatic discharge protocols in place, but oh well. By the way, the little trim pot right here determines the blink rate. So if it's all the way to, let's see, all the way clockwise, you get 4 short blinks and it's on steady, and if you put it all the way counterclockwise, you get 4 long blinks and it's on steady. And right in the middle it does this, which I think is about right. I'm going to leave it there. After a bit of modification to the box, got rid of a couple of standoffs down there for mounting and cutting down the heat sink just a little bit. I've managed to get this down to the height where it will fit in the box, including the heatsink. Now I just need to get the LED down to the level where the top goes on, and the LED will just poke out a tiny bit. Let's see how that worked out. Perfect. There we go. LED in place. Now I've got 4 screws to put in place on the case, and that's it. It'll be ready to mount up on the motorcycle. So everything's done. It's all in the box. It's ready to mount in the motorcycle seat. There it is, 4 blinks and on steady. Now we need to figure out where we're going to put this on board on the seat. And I've got the seat here in the shop. Let me set it up here and we'll see what we can do. So here's that beautiful seat from the Sabre Cafe project. People that watch that know all about how this was made, and that's probably quite a few of you out there. There's the tail light. This is my connections for the tail light. One of these is a ground, the other one's the brake light, and the other wire is for the parking light, the tail light. So I need to put the box in here somewhere, and what I need to do is take the wire that goes to the brake light, and I need to cut that and then link it here on this between let's see, the input side would be the red wire, and then the output side would be the yellow wire going to the brake light. And then of course the green wire goes to ground. So this is where the battery is on the bike. When I set this down onto the frame, this cavity right here, I opened all of this up for future hopes of maybe putting something in here, a compartment where I can stash a small toolkit, maybe spare parts, something like that. So this is a good location to put the box. I can just run a few wires up here around the battery area and mount the box down here somewhere, maybe with a Velcro strip. Pretty easy to do. First order of business is to pull the tape back off from this splice that I did. I put this on here just to make the seat easier to take off and on. I just put a Molex connector plug that I salvaged from some parts I had around here. And these are all shrink wrapped, so I need to determine which one is indeed the brake light, and I can do that with my power supply here. Just let's see, let's make sure we get everything connected right. The ground wire is the bare one. That's right there. And then I've got two other wires, and one will be brighter than the other here on the light when I trigger it. It definitely looks like that's the brighter one. That's the white wire. Yeah, that's it. The white wire is the brake light. So that's the one that I need to disconnect right here and then connect to the box. Get the shrink wrap cut away. Get this unsoldered. So in typical Hack a Week fashion, I decided that I would like to mount this box underneath this area. So I'm taking out some of the foam in here. Start chopping some of this out of the way and mount that box right there. There we go. I need to put something on there to keep that in place, I guess, when I pull the seat off so it doesn't just fall out. So how about some good old heavy duty 3M duct tape to the rescue. That does the trick. Nice package tucked away down in there. Now we just have to wire it up. First I'll solder up the ground wire. Got the third hand tool in here now to help me out. And now I'll solder up the wire that comes from the brake light switch. And now we get the wire that goes to the lights from the timer box. That's it. Everything's hooked up. Now we can test it. We'll connect the ground wire and then touch the positive to the white wire, and the light should blink 4 times and then stay on. How about that? It works. All that's left now is to put it on the bike. Too bad I can't go ride today. Stop! Don't hit me! Maybe that'll get their attention. Well, that's a pretty neat little project. That 4060 timer is a pretty cool little chip. They used to use timers like that in older analog computers on cars, on early fuel injection systems. Just cascade the timers, and the way that they changed that length of time would be based on some resistor value on a component that was measuring the load on the engine. So they're really versatile. You can use them for all kinds of things. They're really well suited for longer term timer functions, a little easier to use than the 555 in that regard. And you can also hook an external crystal to these, like I mentioned, and get a very precise timing if you want. So if you want to know more about the 4060 timer, then go to www.hackaweek.com, find the page about it, just type 4060 in the search and you'll find it. That's this week's blog post. and it will have schematics there on this circuit, or you can buy this kit from Tata Electronics. They're pretty cool. Check out their website. And let's see what else I'll have there. Some information about the 4060, maybe links to data sheets, how to calculate those resistor capacitor values, some links to a few other sites that have info about the 4060. So it's 2014. This was the first video, and there's way more to come. The CB750F is coming up real soon. I know a lot of people are really champing at the bit on that one. That will probably realistically get started in February. I may do a video this month. Short one just about the engine. Get the engine out, take a look inside, make sure everything's there, see what I've got to do to put the engine together first. That is the first thing that has to happen on that motorcycle project. So the new year is going to be full of a lot of electronic stuff, some other things, maybe a bit of metalworking, welding, some food stuff. I'm going to be all over the place. That's what Hack a Week is all about. So if you like the videos, go to the website, hackaweek.com, click on that little donate button and toss a few bucks my way. You don't have to, but if you want to, hey, it helps me out a lot. It costs me a little bit of money to get all this going, but all I ask is that you just appreciate what I do. Well, anyway, what else? Forum. I may do a forum on the website. Watch out for that, and we can discuss things there rather than in the lame, now crippled YouTube comment section. Don't know what they were thinking on that. They're all about trying to get people over to Google+. That's about the gist of it, I think. So that wraps up this week in the 4060 timer. Till next time. We're back, and we're in the Hack Shack with the 4060 thingy timer, and it times things. It's about time.